Okay, so today we're going to be looking at section 7.2, systems of linear inequalities. So what is a system of linear inequalities in two variables? An inequality that divides the coordinate plane into two halves by a boundary line where one half of the plane represents the solutions of the inequality. Okay? That's what a linear inequality in two variables is. How do I graph a linear inequality in two variables, you ask? Well, I will tell. Here's what we're going to do, and then I'm going to do an example for you. Okay? So, this, by the way, is what it's going to look like. This is a linear inequality in two variables. It has the inequality symbol in it, two variables, x and y. Okay? It looks very similar to a line. And so we're going to graph that and show you the solution to that equation, to that inequality. We're going to graph the boundary line. Okay, I'll show you what that is here in a minute. That would usually in the form of y equals mx plus b, but it can be in any form of the line. Okay, if you give it in standard form or slope-intercept form or any form, that's the boundary line when it's an equal sign. These symbols that indicate how you're going to draw your line. This symbol's right here, the less than or greater than symbol, means that the boundary line, okay, between our solutions and non-solutions will be dotted. You're going to draw a dotted line, and the dotted line indicates in our graph that the points on the line are not part of the solution. Whereas when I have this symbols right here with the or equal to parts, so less than or equal to, greater than or equal to, then you're telling me that the boundary line is part of the solution, and so we will draw it with a solid line. This is very important to remember these two things because they continue on from now until forever. Determine which side of the boundary line contains your solution, because the boundary line separates the entire coordinate plane in half, and only one side of that line is the solution. So there's a couple of ways you can do it. I'm going to show you the test point method, which basically means you just pick any point that's not on the line. Either side, doesn't matter, just pick any point, usually the easiest point possible. If it doesn't go through 0, 0, then choose 0, 0. That's the easiest point. We're going to plug that point into the inequality, and then we shade where it's true. So if the point is true when I plug it in, I get a true statement, and I shade the side where the point was at. And if it's false, then I shade the other side. Because the boundary line is a line, you want to make sure you label 2 points. Make sure you name the inequality, and it's that simple. Now, let me show you how this works. Okay, so keep all that in mind right there, and let's do an example. So at this point, you can pause and copy all that down. All right, let's go do this example. So my boundary line is going to be this same thing, but with an equal sign here. Okay, so my boundary line would be y equals negative 3x plus 5. And so I want to be able to graph that. Okay, so I pick points on my table. So here's 0, here's 1, here's negative 1. And if I want to do another point, I can. Here's 2. Plug these numbers in, gives me 5. If I plug in a 1, negative 3 plus 5, that's 2. If I plug in that, it will be negative 6 plus 5 is negative 1. And this over here will be 8. You notice that we're decreasing by 3 each time, hence our slope is negative 3. So we're going to put these dots on our graph paper, and then we're going to draw our boundary line. 0, 5, 1 goes to 2, 2 goes to negative 1, and so we want to line that up and draw with our straight edge. Now, before you draw it, take a moment. Do I draw a dotted line or a solid line? Because that is strictly less than. I am drawing this as a dotted line. The most common mistake people make is they draw the wrong thing. They get going, they get excited, they keep moving, and they forget that this is supposed to be a dotted line. I say this because I'm one of them. Sometimes I forget that I have to draw it as a dotted, And so then I end up drawing it solid, and I have to go back and fix it. So that is my boundary line. This continues on forever and ever and ever. So that is the separation between this side and that side. That's the halves. This half of the graph, that half of the coordinate system. So one side is a solution, one side is not. So we don't know which one, so we do a test point. Pick any point that is not on this line. Again, since 0, 0 is right here and not on the line, I'm going to choose the 0, 0. It's the easiest point. But I can choose any point. Doesn't matter. Either side, I can pick any point. Either side, I can pick 4, 4 if I wanted to, and still work. Okay? So if I pick 0, 0, I'm going to plug in 0 for y and 0 for x. 0 is less than negative 3 times 0 plus 5. So the 0 less than 5. Is that true or false? 0 is indeed less than 5. That is true. And since 0, 0 is here, this is the side that is the solution. Now, how do I indicate my solution? Because every point over here is the solution. Any point on this side of the line will satisfy that inequality. So to indicate that, we do it by a shading technique. Keep it simple, don't scribble, but basically just draw little line segments like this in the indicated side that you are shading, just like so, and you have drawn your solution region. Okay, that's indicating to anybody looking at it that this side of the line is where the solutions are, this side of the line is where the solutions are not. You need to label points because it is a boundary line. Here's 2, negative 1. Here's 0, 5. And you should always write the name of the inequality. Y is less than negative 3x plus 5. This graph is complete. Okay? So that is how you graph an inequality, a linear inequality. Please note again, every point in the shaded region is a solution to this inequality. Every single point. So it's not just one point, it's all the points over here. And none of the points on the boundary line itself. Okay, and nothing on this side. The boundary line is not included in my solution. All right, so let's take a look at another example that we're going to be doing using inequalities. So if you can graph a linear inequality, then you can graph a system of linear inequalities. Okay, a system of linear inequalities is a system of 2 or more linear inequalities. What is the solution going to be? It's all the points that make all the inequalities true. This will be a region in the coordinate plane where the solution regions for each inequality overlap. Okay, how do I do this? Pretty much the same thing. You're just going to graph every single boundary line in your system. Okay, you're going to determine the shading for each of those lines, and then where the lines, the regions intersect, that is your overlap and the solution. Okay, you want to be very careful in your shading in this one. You want to shade in a different fashion for each inequality in your system so that you can see the overlap very clearly. Make sure you name each line and label everything appropriately as we go. Let's do an example. Here's my example that I have prepared for us. Okay, I have 2 lines, two inequalities. We want to graph the boundary line for each one of these things. So you can make a table for each one. So x, y, plug in 0, 1, negative 1 for the top one. If I plug in 0, I'll get a 2. For 1, I'll get 0. And for negative 1, I'll get a 4. Plug in this one here. Plug in 0, 1, negative 1. I'll get a negative 1 here. If I plug in 1, I'll get a 2. And if I plug in negative 1, I get negative 4. So do one at a time. Okay, do one at a time. Here we go. Let's graph the top one. 0, 2, 1, 0, negative 1, 4. This is the top one, and it gets a solid line. So real quickly here, solid line. Now, I reserve my shading till later, and I reserve my labeling till later. You can label the line right now just so you don't forget which one it was you graphed. Okay? And now let's go graph the other one. So 0, -1, 1, 2, -1, -4, and we draw that line, and it has to be dotted. So line everything up, draw your dotted line. Go ahead and label that one. Okay? Now, I go back and I do my shading, starting with the top line. I can do a test point for the top line. Notice 0, 0 is not on any of the two lines, boundary lines, so I'm going to use it for each one. So for this one right here, the solid one, I'm going to plug in 0 is less than or equal to -2 times 0 plus 2. Is 0 less than or equal to +2? That is true. So I'm going to be shading downward. So pick a direction to shade. Okay, you want to shade it very lightly. Don't go dark. Go all the way across, just like so, because you're looking for a region where they may overlap. Now let's do the bottom one here. Again, 0 greater than 3 times 0 minus 1. Is 0 greater than -1? That is also true. Okay, that is also true. 0 is indeed greater than -1. So I'm going to shade the dotted line on this side also. So I want to shade it in a crisscross pattern with the one shading I did before. So I'm going to shade it this way. Like so. And so if you do that, you can clearly see that where the crisscross is your solution. And what I usually do is I usually darken it in some fashion, highlighting it, outlining it like so, making it a little bit darker than all the rest. Like that. Sometimes I'll use, if I'm using pencil, I'll just rub it like this, and it kind of makes a nice highlighted region. So it stands out, from all the rest. But darken it in, you can highlight it however you want to do it. So you can see where the crisscross pattern region is. This region is your solution. Now remember, these lines go on forever, so the solution is very large over here. We still need to label some points. 1, 0 for this one. -1, 4 for that point. This point right here is 0, -1. And I need another point. And let's do 1, 2. So I've labeled 2 points on each line. I've labeled the lines. I've done my shading region. I've darkened the region where the solution is, so it's a lot easier to determine where it is. This is what the solution graph would look like. Okay, you can also just leave it where the crisscross is at. You don't have to make it any darker. It just looks nicer when you do. Okay, so that is solving a system of linear inequalities. Okay, you'll be asked to do this kind of a graph on your test also. So that concludes this video, and we'll do more examples together.